Today we're doing a deep dive on a piece of hardware that is, I think, a real unsung hero. It's something you don't think about until you absolutely have to.
Exactly. We're talking about the Kramer OSP-MM1. It's an optical SFP plus transceiver.
Right, and we've got the data sheet and the manual right here. And I think our goal today is to unpack why this little module is so critical when regular old copper cable just won't do the job.
Well, yeah, because copper hits a wall, a very hard wall.
100 meters, right. That's pretty much the limit if you want any kind of serious bandwidth.
It is, but this module, this thing just blows past that. We're looking at specs that say it can go up to 3 kilometers.
3 kilometers, that's what, about 1.8 miles? That's incredible.
Over the right kind of fiber, yeah. It's literally the bridge between the electrical world inside your switch and the world of light inside the fiber network.
Okay, so let's break that down. The name itself, SFP+. I see that term all the time. It stands for Small Form Factor Pluggable Plus. Yeah.
Correct. It's just the standard. The plus is the important part here that tells you it supports the higher speeds. We're talking up to 10 gigabits per second.
And it's pluggable, so you just slot it into a compatible port on a Kramer switcher, for instance.
And that port is now an optical port. It's now speaking laser, basically.
Speaking of lasers, the datasheet mentions a very specific wavelength, 850 nanometers. Why that number?
850 nanometers is kind of the sweet spot for multi-mode fiber. It lets them use these transmitters called VCSELs.
VCSELs.
Yeah, vertical cavity surface emitting lasers. All you need to know is they're really cost-effective and super efficient for these kinds of distances.
When you say these distances, 3 kilometers can cover a massive corporate campus or a hospital.
Oh, easily. And at a data rate that's, well, it's very intentional. It maxes out at 10.2 GBps.
Which is not a random number. That 10.2 gives you just enough headroom to run uncompressed 4K video at 60 hertz.
Exactly. So if you're an AV integrator and you need a perfect, pristine image from an operating room to a lecture hall that's a mile away, this is how you do it. This is your pipe.
And you're doing all that with just 1 watt of power. That's what the spec says.
It's incredibly efficient.
Okay, so it's fast, it's efficient. But I want to get to the warnings. Because I was reading the manual, and there's some very specific bolded text about the connectors.
Yes. And this is probably the #1 place where an installation goes wrong. It's so easy to mess this up.
So it uses LC connectors, which are common, but it's about the polish on the fiber tip, right?
It is. The manual is very clear. You must use PC or UPC polished connectors. That's physical contact or ultra-physical contact.
Which means the little glass tip is basically flat or just a tiny bit domed.
Right. And the warning explicitly says, do not use APC connectors. Angled physical contact.
Which is funny because you hear the APC is sometimes better because that angle cuts down on reflections.
In some applications, sure, but not here. It's a complete showstopper. If you plug an angled connector into this flat port, you create a tiny air gap.
Ah, so the light just hits that angle and bounces back or refracts all wrong.
You get massive signal loss, or more likely, just nothing. The link won't even come up.
So the practical advice for anyone listening is check your patch cables. Usually green connectors mean APC.
Right. Blue often means UPC. If you see green, keep it away from this module. It's a precision instrument. It is a class 1 laser, so it's eye-safe, but it relies on that perfect physical connection.
Good to know. And one last thing, it's listed as hot pluggable.
Which is a huge deal. It just means you don't have to power down a whole rack of expensive gear just to swap one of these out. You can do it live.
And because it's Kramer certified, you know it's just going to work with your equipment. No fuss.
It'll handshake perfectly.
So to sum it all up, this little box, the OSP-MM1, is like a range extender on steroids. It takes a 10 gig signal that would die on copper after 100 meters and just shoots it for miles using a beam of light.
That's it in a nutshell. It's what makes campus-wide 4K video even possible.
It really just erases distance from the equation. Which leaves me with a final thought for you to chew on. We're solving today's 4K problem with 10 gigabits of light. But as we all move toward 8K uncompressed VR, our data needs are just going to explode. We're getting a handle on 10G now, but you have to wonder, how long is it until even a beam of light isn't fast enough?
Or at least until we need a whole lot more of them.
Something to think about. Thanks for listening to this deep dive.